The interstellar visitor named 3I Atlas has returned, but it's strangely growing brighter, pulsing with strange energy after its trip behind the sun, and astronomers are baffled.
3 days ago, something just happened 126 million miles from Earth that made NASA scientists go completely silent. Not because they were scared, but because nobody predicted it. On October the 29th, 2025, the comet known as 3I/ATLAS, only the third interstellar object ever seen passing through our solar system, hit its perihelion, its closest point to the Sun. But instead of breaking apart or burning up, it did something no model said it could. It accelerated, brightened, and changed composition, like it was alive. And when you understand what scientists actually discovered, you'll realize this comet is a message from billions of years in the past, rewriting everything we thought we knew about the cosmos. But first, how did something this ancient and this alien even get here? The impossible arrival. Imagine discovering something that came from another star system entirely, not in science fiction, but happening right now. On July 1st, 2025, the Atlas telescope array in Rio Hurtado, Chile. But here's what made this discovery different from the previous 2 interstellar objects we've ever found. Astronomers could barely believe the data they were seeing. On July 1st, something incredibly rare happened, but almost nobody noticed. Just after midnight, the ATLAS survey team picked up a faint object gliding across the southern sky. It looked like any other comet, except for one detail. It was moving too fast. When they ran the numbers, its speed made no sense for something bound to our Sun. This object, later named 3I/ATLAS, was cruising at nearly 58 kilometers per second on a hyperbolic orbit that couldn't possibly belong to our solar system. Translation: it didn't come from here. At first, astronomers thought it might be a glitch, but then more telescopes joined in. The Zwicky Transient Facility confirmed the object, and by July 2nd, the Minor Planets Center made it official. Humanity had just spotted the third interstellar visitor in recorded history. To understand how big this is, let's rewind. In 2017, we had Oumuamua, the first interstellar object ever seen, long, flat, and spinning like a piece of alien hardware. 2 years later came Borisov, which behaved more like a typical comet, but still didn't belong here. Both were brief cosmic drop-ins, gone before we could properly study them. But 3I/ATLAS, this one was different, bigger, brighter, slower to fade. It gave us time, and the maths didn't lie. The object's eccentricity, around 6.1, proved it wasn't orbiting the Sun. Its path, nearly 175 degrees retrograde, meant it was slicing through our solar system in the opposite direction of everything else. A rebel from deep space, casually breaking every rule in celestial mechanics. Then came the kicker: size. Using NASA's Hubble Space Telescope, researchers estimated its nucleus could be up to 1 kilometer wide, surrounded by a glowing coma over 348,000 kilometers across. That's wider than the Sun itself. Just imagine a ghostly halo stretching past the edge of the solar disk, drifting silently through space. And get this, astronomers later realized they'd been tracking it since mid-June, weeks before the official announcement. The more they looked, the stranger it became. How could something this ancient, this massive, and this alien stay perfectly intact after traveling for billions of years between stars? So, what makes 3I/ATLAS truly different from the cosmic guests before it? The answer isn't just where it came from. It's what happened to it during its journey. Because when scientists finally pointed their most powerful instruments at this visitor, they found something in its composition that shouldn't exist at all. What exactly was this comet made of? The composition shock, what James Webb revealed. When NASA's instruments locked onto 3I/ATLAS, astronomers expected the usual: water ice, a little dust, maybe traces of carbon monoxide, typical comet chemistry. But what they actually found sent every space agency back to the drawing board. The James Webb Space Telescope caught its first glimpse of 3I/ATLAS just days after its detection. Using its near-infrared spectrograph, NIRSPEC, Webb measured how the comet's gases absorbed and emitted light. What it revealed didn't match any known profile of a solar system comet. Instead, the readings lit up in a way that screamed carbon dioxide, an enormous amount of it. Now, that might sound trivial. Comets have carbon dioxide, right? Sure, but not like this. According to the official NASA and ESA joint update, 3I/A TLAS wasn't just rich in CO2, it was dominated by it. Nearly 80% of its volatile composition appeared to be frozen carbon dioxide, with almost no trace of water ice. To put that in perspective, most comets we know are water-rich, with only a thin frosting of carbon dioxide. But this one, it was a dry, frozen husk made almost entirely of alien carbon dioxide, and that alone breaks several cosmic rules. You see, carbon dioxide ice is volatile. It evaporates fast, even far from the sun. A comet made primarily of it shouldn't have survived a billion-year journey through interstellar space. It should have disintegrated long before reaching us. Yet somehow, this one stayed intact all the way to its perihelion on October the 29th, 2025. At the same moment, it brightened instead of burning up. That brightening wasn't random. As the comet neared the sun, instead of shedding gas in a chaotic spray, Webb observed a structured burst, like controlled jets firing from specific regions. That's not something comets do naturally. It's what you'd expect from pressure vents or a body with internal architecture. Cue the online frenzy. Within hours of the Webb data release, Reddit threads, X accounts, and even a few fringe scientists started calling 3I/ATLAS the alien cryo capsule. Others theorized it might be the fragmented core of a planet from another system, its atmosphere frozen solid after its star went supernova. NASA scientists weren't ready to go that far, but even they admitted this object's carbon ratio doesn't match anything in our local stellar neighborhood. Translation: its chemistry belongs to a completely different kind of solar system, one that formed under colder, darker, more distant conditions than ours. And then came the weirdest part. Using data from Webb, Hubble, and ALMA, researchers discovered something else hiding in the gas plume: complex organics, molecules like formaldehyde and methanol, the very precursors of life. In other words, 3I/ATLAS wasn't just an interstellar rock, it was carrying the chemical seeds of biology. That realization turned this from an astronomy story into an origin story. If comets like 3I/ATLAS roam freely between stars, ferrying organic material, then life, at least the chemistry that enables it, could be spreading across galaxies. The phenomenon is called panspermia, and 3I/ATLAS might just be the first physical proof that it's possible. Still, there's one last mystery. Why did this comet, alone among its interstellar peers, survive? Oumuamua tumbled and dimmed. Borisov broke apart. But 3I/ATLAS, it held together and even thrived when it hit the most dangerous part of its orbit. One theory suggests that beneath its carbon dioxide crust lies a metallic shell, a core denser than ice, possibly enriched with nickel or iron, something forged in the explosion of a dying star. If that's true, then 3I/ATLAS isn't just old. It's prehistoric, a relic from a system that existed long before ours ever formed. And when the Webb telescope zoomed in for one final look as it drifted away from the sun, it caught a spectral signature nobody could explain. A repeating infrared pulse, consistent, rhythmic, almost deliberate. Coincidence? Instrument glitch? Or something else entirely? Because if that pulse wasn't random, then 3I/ATLAS might not just be an interstellar traveler. It could be a message frozen in motion, a billion-year-old broadcast crossing the stars. So now the question isn't where it came from, it's who or what sent it. The impossible brightening, Perihelion chaos. When 3I/ATLAS finally swung around the sun on October the 29th, 2025, astronomers expected fireworks. But not this. Comets usually fade as they near perihelion. Their icy shells boil off, they fragment, and they die. But 3I/A/TLAS, it defied every rule in the celestial handbook. Instead of dimming, it flared. In the hours leading to closest approach, instruments from NASA's Solar Orbiter and ESA's SOHO satellite caught something no one could explain. The comet didn't disintegrate. It brightened nearly 600%, its coma expanding like a living thing. The outburst was so intense that it temporarily rivaled the brightness of Mercury. At first, researchers thought they were watching a breakup, but as the dust cleared, literally, the object was still intact. No fragments, no debris trails, just a perfectly symmetrical core glowing in pure infrared. That was impossible. The Jang and Batams, 2025, preprint on Arxiv put it bluntly. The energy signature observed during perihelion exceeds predictions by an order of magnitude. The nucleus remains cohesive, suggesting active heat redistribution. This meant that something inside the comet was managing the heat, and it gets weirder. Data from NASA's Parker Solar Probe, passing just 10 million kilometers away, picked up electromagnetic fluctuations as the comet peaked in brightness. Regular, rhythmic pulses, about 1 every 23 minutes, the same frequency Webb had seen earlier in infrared. Coincidence? Maybe. But here's the kicker. Those pulses intensified exactly when 3I/ATLAS crossed the Sun's magnetic equator, almost like it was responding to the solar field. Now remember, this object isn't native to our system. It's been drifting between stars for billions of years. For it to survive a full solar pass intact means it's built from material tougher than anything we've ever found, possibly metal-rich carbon composites, the kind formed only in the cores of supernova remnants. In other words, this thing could be a fragment of a dead star coated in carbon dioxide ice. As scientists debated, one phrase kept surfacing in private research forums and leaked observatory memos: artificial thermoregulation. Was this comet actually controlling its own temperature? To the public, NASA kept it cautious. 3I/ATLAS exhibits highly unusual stability under extreme thermal stress. But in the data notes, quietly uploaded to the Minor Planet Center's archive, there was a line that read like science fiction. Internal structure suspected. Reflectivity inconsistent with porous ice. Possible subsurface stratification or engineered lamination and engineered. That word shouldn't appear in an astrophysical summary, but it did. Then came the final twist. Just as 3I/ATLAS cleared perihelion and began drifting back toward the outer solar system, the rhythmic pulses stopped. No gradual fade, just silence. Within 24 hours, the brightness dropped back to baseline, as if it had powered down. Today, the object is heading toward deep space again. Still intact, still glowing faintly in infrared, carrying its secrets with it. So, what happened near the Sun? Did we just witness a natural phenomenon unlike anything before? Or the first sign of interstellar engineering? Because if that light wasn't a flare, if it was a signal, then we might have just watched the universe blink back at us. The galactic journey, a fossil record of billions of years. Think about that for a moment. 3I/ATLAS traveled through the absolute void of interstellar space, the frozen, irradiated darkness between stars, for billions of years. And the evidence for this ancient journey is literally written into its chemical composition. When Perez, Couto, and colleagues traced 3I/ATLAS's orbit backward through 10 million years of cosmic history, they discovered something profound. There were no recent stellar encounters that could have altered its path. This object hasn't been disturbed in recent galactic history. It's been drifting since the age of dinosaurs, on Earth, at least. Now, here's where things get mind-bending. Using the Gaia DR3 star catalog, Perez Couto's team simulated the comet's motion backward in time, integrating the gravitational pull of nearby stars and galactic tides. Out of 93 potential close passes, none produced a significant deflection. The strongest encounter, just 0.3 parsecs away, barely nudged it by a few 10,000ths of a kilometer per second. In other words, 3I/ATLAS has been coasting, untouched, for billions of years. Its origin doesn't belong to any of our neighboring stars. It belongs to the deep galactic past. Picture that. A lone traveler ejected from its home system, flung outward after a gravitational scuffle with a planet that might not even exist anymore. Maybe it once orbited a sun-like star. Maybe that star has long since become a red giant or collapsed into a white dwarf. The system could be dust now, but this object kept going, quietly crossing the galaxy like a bottled message floating across a cosmic ocean. And that's exactly what scientists realized. It is a message, just not the kind written in words. The key is buried in its chemistry. When astronomers studied its spectral lines, they saw something shocking, an unusually high ratio of carbon dioxide to carbon monoxide. At first, that looked alien, like it was born in a completely different kind of solar nursery. But the new ARC-Shiv studies flipped that idea on its head. This wasn't an alien fingerprint, it was weathering. Billions of years of exposure to galactic cosmic rays had literally resculpted the comet's surface. Those high-energy particles, traveling near the speed of light, don't just chip away at rock and ice, they rewrite the chemistry itself. They turn carbon monoxide into carbon dioxide. They darken organic material into a tar-like crust, and they do it inch by inch, century after century. That's the real revelation. We're not seeing what 3I/ATLAS was when it left home. We're seeing what it became after an eternity adrift. Every atom on its outer shell carries the scars of that journey. The radiation has transformed its skin into a fossil record, a literal timeline of galactic travel. The outer 20 meters are no longer pristine. They're like the burnt parchment of a cosmic manuscript. This changes everything we thought we knew about interstellar visitors. Oumuamua was the strange scout. Borisov was the young wanderer. But 3I/ATLAS, it's the ancient one, the elder. Its weathering tells us it's been traveling for at least 1 to 4 billion years. That makes it older than most of the planets in our own solar system. And here's the wildest implication. If one such relic made it to us, there must be millions more out there, drifting invisibly through the Milky Way. Some are older, some younger, all carrying chemical memories of the stars that birthed them. Every interstellar object we find from now on will tell the same story. The cosmos recycles worlds. So we're not just staring at a comet, we're looking at proof that planetary systems have been forming, collapsing, and scattering their remnants across the galaxy for eons. 3I/ATLAS is the first to show us how those ancient stories survive, and that answer, what its chemistry really means, reveals something that fundamentally changes how we see the cosmos. So, if this thing has been wandering the galaxy for billions of years, the real question becomes, now that it's brushed past our sun, what happens next? Could it come back? Or was this its final visit? What's next? The future implications of 3I/ATLAS. Now that 3I/ATLAS has passed Perihelion on October the 29th, the show isn't over. It's just the beginning of a new act. The comet will make several close approaches to planets in our solar system over the next several months, each one offering new observation opportunities. But more importantly, this entire encounter has fundamentally changed how we approach studying interstellar objects. Scientists are now asking different questions, looking for different signatures, and understanding what we should search for when the next interstellar visitor arrives. And the answer has massive consequences for how we understand the universe. Because while 3I/ATLAS is now cruising away from the sun, its route still cuts close to several worlds, like a celebrity farewell tour across the solar system. On October the 3rd, it skimmed past Mars at just 0.19 astronomical units. And yes, ESA's ExoMars orbiter even managed to snap it from 19 million miles away. Next comes Venus on November the 3rd, when it'll drift 0.65 astronomical units from the planet. Then, on December 19th, comes the big one, its closest Earth approach. Don't panic though. At 1.80 astronomical units, it's safely farther than Mars's orbit. But still, that's close enough for every major telescope on Earth to get a front row seat. And the last encore, March 16th, 2026, when it swings past Jupiter at 0.36 astronomical units before heading back to deep space forever. So yes, Earth's completely safe. No impact, no close shave, no Hollywood disaster plot, just pristine, once-in-a-lifetime science. And for amateur astronomers, December 2025 will be the month to remember. Under dark skies, 3I/ATLAS will hit magnitude 9, bright enough to catch with a decent pair of binoculars or a small backyard telescope. Citizen scientists from around the world will help refine its orbit, prove its stability, and maybe even track how its brightness shifts minute to minute. This is cosmic exploration made democratic. But beyond the spectacle lies something more serious. 3I/ATLAS has just validated every part of our planetary defense system. The Atlas survey that first spotted it, it worked flawlessly. The rapid multi-mission coordination between NASA, ESA, and observatories worldwide, also flawless. This wasn't just about discovery, it was a stress test for humanity's early warning system, and we passed. The science legacy is just as big. We now know interstellar comets can carry CO2-rich chemistry that's shaped by billions of years of cosmic ray exposure, teaching us how planets evolve beyond their home stars. Every telescope, from Webb to Subaru, helped refine how we detect water, ice, and organic molecules in objects so faint they barely reflect sunlight. And that's going to completely reshape exoplanet research, because if comets like this can travel between stars, then so can the ingredients for life itself. 3I/ATLAS doesn't just change how we look at comets, it changes how we see ourselves. It proves that planetary systems constantly eject material, scattering their building blocks across the galaxy, that the cosmos is a living network of exchange, not isolation. So, when you look up this December and spot that faint, glowing traveler, remember, you're not just seeing a comet, you're watching proof that the universe shares its stories, its chemistry, and maybe even its origins of life. But the real question now is, what if the next interstellar object isn't a comet at all, but something built to last? So here's where we land. 3I/ATLAS wasn't just a comet, it was a revelation. Proof that the space between stars isn't empty at all, but alive with travelers carrying chemistry, memory, and maybe history. The real shock wasn't what it did near the sun, but that we were finally sharp enough to see it. Our tech, our teamwork, and our timing all collided at the right cosmic second. And now, the next interstellar visitor is already on its way. But what if it's not made of ice and dust this time? What if it's something built? Let us know your thoughts in the comments section below.